Bismillahirrahmanirrahim. Assalamu alaikum. Today our topic is Unit 8, Place on the Crust. Place on the Crust, course book page number 94-96. So, on the screen, what do you see? Yes, of course, it's a picture of our Earth. Do you know about the composition of the Earth or what Earth is made up of? Yes, the Earth is made up of several elements like oxygen, silicon, aluminum, potassium, sodium, iron, calcium, oxygen, silicon, and magnesium. And its composition consists of a series of 4 layers. What are those? Crust, mantle, outer core, and inner core. So these are the 4 layers of the Earth. So, starting with the structure of the Earth, we'll start with the inner core. The innermost part of the Earth is composed of iron and nickel. The inner core and the outer core both are composed of iron and nickel. And the inner core, the planet's center, is enveloped by the outer core, which has liquid properties. Mantle is the middle layer of the Earth, up to 2,800 kilometers thick. The upper part forms the part of the lithosphere. The mantle's upper part forms the lithosphere. The mantle's upper part forms the lithosphere. So, and it is rigid. The lower semi-molten part forms the asthenosphere. So, and the crust is the outer layer, and it is 75 kilometers thick. So, we have a further description of the Earth's layer. The crust is the solid layer of a rock on the surface of the planet. The thickness varies between 3 to 30 miles. Then the mantle is the semi-liquid layer of the magma, the molten rock that moves due to the convection currents. We learn about the convection currents in our text. Outer core, the liquid part of the core, which has a similar composition to the inner core. That means the inner core and the outer core both have the similar composition. The inner core is a solid part at the center of the Earth. It is made up of iron and nickel and has the temperature reaching from 5,500 Celsius. So now you look at this picture. This is the structure of the Earth. It gives you a clear picture of the inner core, the outer core, the mantle, and the crust, and their distance, their depth. 800 miles is the inner core, 1400 miles is the outer core, 1800 miles is the mantle, and 5 to 25 miles is the crust. So, when there is disturbance in these layers, we face earthquakes. We have faced major earthquakes in the past. There was a major earthquake in 2008 in Ziyarat, the area of northern Pakistan. To get to know how these earthquakes occur, we have to study the layers of the Earth. Now open up your books to page number 94, the Earth's layer. So, I'll read the first para and then explain it to you. The Earth's layer, the Earth's hard outer layer is called crust, extending only from 5 to 50 kilometers deep. It is remarkably thin compared to the 6,000 kilometers spanning the Earth's surface and its center. So, the Earth's hard outer layer is called crust, extending. It ranges from only from 5 to 50 kilometers deep. That means that the area of the Earth's crust is only 5 to 50 kilometers in depth of the Earth. It is extraordinarily thin. It is extraordinarily thin as compared to the distance of the Earth's surface to its center, that is 6,000 kilometers. The crust makes up less than 1% of the Earth's mass, consisting of thin oceanic crust that underlies the oceanic basins, and the thicker continental crust that lies the continent basin. These two different types of crust are made up of different types of rocks. So I'll come to the second para. About 30 years ago, geologists discovered that the crust is not one solid piece. Instead, it is split into separate slabs that are now commonly referred to as plates. The plates float like giant rafts, one on top of the lowermost layer, the crust, and the upper part of the mantle, which is the layer immediately below the crust, together forms the lithosphere. So, about 30 years ago, geologists discovered the crust is not one solid piece. So, who is a geologist? A geologist is a specialist in geology, and a geology is a science that deals with the history of the earth as recorded in rocks. They discovered that the earth crust is split into separate slabs. That means it is broken into large, thick pieces of stones and are a part of each other and are a part of from each other and are commonly called plates. So they are commonly called plates. These plates float, that means these plates drift, they move like giant rafts. Giant rafts means a great mass of land on top of the lowermost layer. One on top of the lowermost layer, the crust and the upper part of the mantle. Mantle is the section under the earth's crust of the earth, which is the layer immediately below the crust and is also called outer mantle. So the crust and the outer mantle together forms the lithosphere, which is a solid part consisting of the crust and the outer mantle. The mantle is hot and represents 68% of the Earth's mass. So here we have a question. What do plates refer to? I'm sure you know the answer now. The crust is not one solid piece. It is divided into separate slabs that are called plates. These plates float like giant rafts, one on top of another. So this is the answer to it. So I'll come to the para 3. About 300 million years ago, there was only one large continent that geologists call Pangaea. Gradually, the continent began to break up into separate places. Since then, the places have been moving about in all directions. Places that were once near the equator are now much further north. The fact helps to explain why limestone containing coral fossils is found in places where it is now far too cold for coral to grow. So, geologists have explored the structure of the Earth's crust and its evolution over time. About 300 million years ago, there was only one large continent which was named Pangaea by the geologists. The continent gradually, slowly broke up into places which were apart from each other and still continued to float slowly in different directions. Oceans and seas have been formed as a result of this phenomenon, as the result of this development. So, places that were near the equator, which is equator is an imaginary line around the center of the Earth, so are now moving further north. They have moved further away to the north, and it explains the fact that why limestone, which is a sedimentary rock, consisting mainly of calcium that was deposited by the remains of marine animals containing coral fossils. So, coral fossils are found in places where it is now far too cold for coral to grow. Coral fossils are red or pink colored fossils, that means the remains of plants and animals that existed in the past geological age that has been discovered by digging the soil. So coral fossils are found in these cold areas where it is not possible for coral to grow due to cold temperature. So we'll move to para number 4. The crust now has about 15 large plates and several smaller ones. They move very slowly, about 2 to 4 centimeters every year. This does not seem fast to us, but geological time is measured against millions of years. Geologists, going by their own calculations, believe that the speed is strong enough to open up an ocean 2,000 kilometers wide in about 50 million years. In fact, the Atlantic Ocean has opened up in this kind of time frame. It is thus evident why some of the older rocks, such as coal, are found to be of the same kind on both sides of the Atlantic Ocean. So, the crust now comprises about 15 large plates and several smaller plates. They move a distance of 2 to 4 centimeters every year, and this movement is very slow. This movement does not seem fast to us, but the geological time means that the time of physical formation and development of the earth is measured or calculated against millions of years. According to the calculations of the geologists, they believe the speed is strong enough to open up an ocean 200 kilometers wide in about 50 million years, meaning that the drifting of the plates results in the formation of seas and ocean after a certain million years. In fact, as a matter of fact, the Atlantic Ocean has opened up in this kind of time frame. Atlantic Ocean was not on the face of the earth until 130 million years ago, when Pangaea started splitting apart and water from Panthalassa, the ancient superocean, started filling the gaps formed between African plate and the South American plate, forming the Atlantic we see today. Forming the Atlantic we see today. It is evident, clearly revealed by some of the older rocks such as coal are found to be of the same kind on both sides of the Atlantic Ocean. Now we have a question, how many plates are there now? Yes, it's in your para. The answer is in your para. The crust has about 15 large plates and several smaller ones. Yes. So now we will study why the plates move. We have to know why the movements of the plates occur. So I'll read the para number 5. It is quite evident that a phenomenon is taking place inside the earth and shifting the plates around. It is hard to find out the exact nature of this phenomenon, as it is not possible for anyone to go that deep inside. The molten rock thrown up by the volcanoes contains clues about what may lie deep under the crust. Shock waves from earthquakes also give indications about the inside of the earth. So it is quite evident, it is quite clear that the phenomenon, the development, the occurrence is taking place inside the earth and shifting the place around. It is hard, it is difficult to find the exact nature. That means every detail of the phenomenon, the development, and it is impossible for anyone to go deep inside the earth. The molten rock, which is also called magma. I'm giving you the name of the molten rock. The molten rock, which is also called magma, is thrown up by the volcanoes, contains clues that it provides with the helpful information about what lies deep under the crust, what is inside the Earth's thin layer. So, what's a volcano? A volcano is an opening in the Earth's crust that allows molten rocks, gases, and volcanic ash to escape to the surface. The magma that erupts is called lava. So, in your book, there is a picture of Oxen volcano, Alaska. So this is the volcano which is in Alaska, and it is the most historical active volcano. So, shock waves from the earthquakes are also called compression waves or seismic waves, are a form of explosion that affects places far away and also give indications or clues about the inside of the earth. So earthquake is a series of vibrations induced in the earth crust by the abrupt rupture, that is the breaking, and rebound, that means recovering of the rocks due to a sudden release of energy in the earth's lithosphere that creates seismic waves. So the question here says, why is it difficult to know how plates move? Yes, it is difficult to know about the movements of the plates it because no one can go deep inside the earth. So we'll come to our sixth para. The inside of the earth is so hot that rocks tend to melt to float. However, they remain partially solid and move only very slowly because of the intense pressure all around. Currents of hot material move towards the crust from inside the mantle. When they reach the mantle, they separate under the crust and flow along in different directions. These streams of hot molten material are called convection currents. The convection currents in the rock push the plates above them and set them moving. As the plates move, they crash into each other, move away, or slide past each other. The pressure that causes these movements are enormous and cannot be stopped. So, deep within the earth is so hot that the rocks are inclined to melt slowly and become thick flowing substance called magma. However, they remain partially solid, means a part of it remains solid and moves very slowly because of the intense pressure all around. There is severe force all around. Current streams of hot material move towards the crust from inside the mantle. As the hot material magma is lighter, it rises. The currents, when reach the mantle, they separate, divide under the crust, and flow along in different directions. These current streams of magma are also called convection currents. The convection currents in rocks push the plates, set them moving. As the plates move, they crash into each other, move away, they slide or glide. While remaining in contact, they pass each other. The pressures, force that causes these movements are enormous. They are tremendous, they are extraordinary, and cannot be stopped. So we'll read para number 7. The plates move slowly, grinding against each other and sending out vibrations through the rocks. These vibrations are felt on the ground as tremors. So the plates move slowly, grinding against each other, that means rubbing together against each other. And they send out vibration, that is the act of shaking, is felt on the ground through the rocks. You feel like the earth is quaking or shaking by the seismic vibration. So tremors are the shaking of the earth. So we'll come to para number 8. Sometimes parts of the plates get locked into each other and stop moving for a while. On such occasions, the pressure to move keeps building up until the plates jolt forward again. All the energy is suddenly released and there is a major earthquake. So sometimes parts of the plates get locked into each other, they become rigid, fixed, or immovable for a while. On such occasion, uh, at this critical time, the moving pressure keeps building up and the moving force becomes stronger until the plates jolt, bump, shake, jerk forward again. all the energy is abruptly, suddenly released, and this results in major earthquake. So now we will have the look at the anatomy of an earthquake. That means we will have a detailed analysis of an earthquake. So the crust is made up of tectonic plates. The crust is made up of tectonic plates, and the point where the plates meet is called the fault. So massive rocks that make up the outer layer of the Earth's surface and whose movement along fault triggers earthquake. And faults are basically cracks between these plates on the Earth surface and within the Earth. So it is a fracture in the rocks that make up the Earth's crust. So this is the fracture, and that is called the fault. And these are the plates of the Earth. Yes. The sudden movement of the rocks along the fault. The sudden movement of the rocks along the fault causes vibration. So these red lines are called vibrations, and these vibrations transmit energy through the earth in the form of seismic waves. So these are the seismic vibrations which are causing seismic waves that transmit energy released by the earthquake. So the point where within the earth where an earthquake originates, the point within the earth when an earthquake originates, that means here the earthquake starts, begins. So it's called focus, where the rupture starts. It is also called hypocenter or the focal. Here the rupture, here the breaking up starts. So the point on the Earth's surface directly above the focus is called the epicenter. This is the epicenter, and it is just above the directly above the focus. So this is how the movement of Earth takes place, and how the plates move, and how the seismic waves happen, and what's the focus and what's the epicenter. So now we move to our picture of how do plates move. So you can see in the picture that there are convection cells, there is a rigid push, and there is a lithosphere. So this image is a cross section through the earth showing convection cells on the mantle. The rigid push happens at spreading the center where plates are moving apart, and slab pull happens at the subduction zone where one plate is moved down into the mantle. Okay, so this is how the plates move. This is a clear picture of the movements. Okay, then we'll come to the words meaning. So you can take the screenshot, and I'll read the words and the meanings to you. Crust is a hard outer layer of the earth. Slabs are larger, thick plates of stone. Split means to break. Mantle, section under the crust of the earth. Lithosphere, outer part of the earth. Equator, an imaginary line around the center of the earth. Coral, pink or red color. Fossils, the remains of plants and animals. Phenomenon is development. Volcanoes are mountains through which lava erupts. Enormous, huge geologist, a specialist in a science that deals with the history of the earth as recorded in rocks. Pangaea, a supposed continent including all the landmass of the earth. Take the screenshot of the word's meaning. Students, we have learned the main causes of earthquake, and when tectonic plates collide one right above the other, causing earthquakes and volcanoes to erupt. So here is a brief summary of these causes. Earthquakes are the vibrations or the shaking of the earth produced by the rapid release of energy when rocks are subjected to large forces such as those associated with plate movements. The rocks are stretched and strained. When rocks cannot withstand the stress any longer, they break or shift and energy is released. The faults are fractures in the earth where movement has occurred. Energy results in vibrations and then earthquake. So these are the causes of the earthquake. So the effects of the earthquake are terrible and devastating. They cause the buildings to collapse, houses are torn apart, people need a new home, they will need to do a lot of work to clean it up. There is rubble everywhere and the cars are smashed. They disrupt transport and services, they cause even fire, and they trigger landslide and tsunamis. Do you know which place has the most earthquakes? Yes, Japan is the place that has the most recorded earthquakes as it sits on highly active seismic area. The strong and large earthquakes typically last 10 to 30 seconds, and aftershocks are felt as the readjustment is taking place in the earth. We have we have learned what causes earthquakes and what is the effect of the causes. Cause and effect play an important part in the universe. We need to understand what is cause and what is effect. Cause is a relationship between the events or things, where one is the result of the other. This is the combination of action and reaction. First, the cause occurs and then the effect. Cause is not always first in the text. I repeat, cause is not always first in the text. Cause is producer of an effect, and effect is produced by a cause, meaning effect is the result of an action of person or the outcome of events that happen. So how are we going to identify cause and effect? Identifying cause and effect in text is important and is as it is help us to understand the events that are happening. It helps us to understand what's happening and why it's happening. So cause and if cause is what happens and the result is the effect. Now you open your books to page number 97, 98, course books to page number 97, 98, level 3 exercise. So level 3, the question is the above passage has many sentences sharing a cause and effect relationship. Explain the relationship between the two statements A and B below. Indicate which of them contains the cause and which the effect. So the statement A says, since then, the plates have been moving about in all directions. And sentence B says, places that were once near the equator are now much further north. So, how are we going to identify the cause and effect? So, we'll ask the questions. The plates have been moving about in all directions. So, what happens after that? Places that were near the equator are now much farther north. So, of course, it answers the question what. And if you see that sentence B, it says they were once near the equator are now much farther north. Why? Because the plates have been moving about in all directions. So the cause asks the question what, and the effect asks the question why. So cause tells us why something is happening, and effect tells us what is happening. So, of course, since then, the plates have been moving about in all directions is the cause, and the sentence B, places that were near the equator are now much farther north is the effect. So, I hope you got how to identify the cause and effect. So, we'll come to question 15. Complete the flow diagram bringing out the cause and effect relationship between the words in the statements. So, below, the statement is the inside of the earth is so hot, the rocks tend to melt. So, of course, we'll again ask the question, the inside of the earth is so hot, so what happens? The rocks tend to melt. And why does the rock tend to melt? Because the inside of the earth is hot. So you get the answer, the inside of the earth is so hot is the cause. The inside of the earth is so hot is the cause, and the rocks tend to melt is the effect. So we'll move to the next question. The rocks remain partially solid and move only very slowly because of the intense pressure all around. So the rocks remain partially solid and move only very slowly. Why? Because the intense pressure is all around. Yes. So intense pressure all around is the cause, and the rocks remain partially solid, move only very slowly is the effect. So the convection currents in the rocks push the plates above them, and as a result the plates start moving. So what happens when the convection currents in the rock push the plates above them? The plates start moving. And why do the plates start moving? Because the convection currents in the rocks push the plates above them. So of course, the convection currents in the rocks push the plates above them is the cause, and as a result, the plates start moving is the effect. I hope you understand what are cause and effect. So we'll come to our home task. The first task is write the word meanings in your exercise copy. Learn the word meanings. Number 3 is do the cause and effect exercise of course book, page number 97, 98 in your course book. And read the unit thoroughly to answer the textual question answers which are to be asked in the next class. So this is for all for today. Take the screenshot of the home task. I hope you have taken the screenshot of the word meanings. I'll show you the word meanings again. Yeah, these are the word meanings. So take the screenshot of the word meanings also. So this is all for today. So Allah Hafiz.